all of these are type 1 cations, which means that I could technically get all of these charges off the periodic chart because they're either in group 1, group 2, or they're aluminum. But what I want you to do is I want you to get into the habit of figuring out the charge on the cation, not by looking at the periodic chart, but by knowing what the negative charges are on the anion side. Now, I'm going to show you how to do that in each of these cases. When we get to the type 2 cations, you won't be able to look at the periodic chart to get the charges on these guys, these ones in the middle. So you're going to have to figure them out using the total of negative charges that you know from over here. Alright, so let's start on this one. We've got NaCl, which is going to be 1 sodium and 1 chloride. If we look at the charges here, we see that Cl is in group 7, so it has a negative 1 charge. That means the total charge here is negative 1, which means the total positive charge is going to be positive 1, which means sodium has a plus 1 charge. So those are the ions there, and that would be sodium chloride. Okay, looking at the next one, we've got Li2O. If I drew a picture of that, it would be Li, Li, and O, because there's 2 lithiums and 1 oxygen. So I go over here, I look for the charge on oxygen, I see it's in the group 6, so it's negative 2. Total negative charge is negative 2. Total positive charge is going to be positive 2 to match for negative 2. So then the question becomes, what value does each of these lithiums have to have in order to get to plus 2? And that would have to be plus 1 and plus 1. So the actual ions you would put down as the answers here would be Li plus and O negative 2. So you just want one of each of these. And the name then becomes lithium, that's for the Li plus ion, and oxide. Notice in both of these cases there's no need to include the charge in the name because we always know that the charge on sodium and lithium is always going to be positive 1 because they're both in group 1 here. So anytime they're in group 1, group 2 or they're aluminum, you never put the charge in the name. Alright, so in the next one we've got Be3N2, and that would be 3 Be's and 2 N's. So I look at that and I say, well, charge on nitrogen, okay, it's in group 5, so it's negative 3. So there's 2 negative 3s, that means that total charge is negative 6. Total positive charge has to be positive 6 because these guys have to match. And now we have to go ahead and figure out what charge beryllium would have so we can get to plus 6. And that would have to be plus 2 for each of these. So the cation would be Be2 plus, the anion would be N3 minus, and the name would become beryllium nitride. And again, no need to put the charge in the name. In each instance, since these are single element anions, these come directly off the periodic chart, we go ahead and we change the root name. Take the root of the name, we add IDE to the end of each of these. Alright, so moving on to the next one. We've got a CAS, that's 1 Ca and 1 S. And if we look at the periodic chart, we see S is in group 6, so it has a negative 2 charge. Total charge is negative 2. Total positive charge has to be positive 2. Calcium will be 2 plus. And the name of this one would be calcium sulfide. Again, no need for the charge in the name because calcium's in group 2 and we always know it has a positive 2 charge. Alright, the next one we've got AlBr3. So when we do this, we'll have 1 Al and then we'll have 3 Brs. If we look at the periodic chart, we see the Brs are in group 7, so they're each going to have a negative 1 charge. So the total charge is going to be negative 3. The total positive charge is going to be positive 3 to match that. And that means that the aluminum must have a 3 plus charge. And if we look over here, we see it's in group 3, so it would have had a plus 3 charge. So the name of this would be aluminum bromide. And aluminum always has a plus 3 charge, so there's no need to put the charge anywhere in the name. Alright, so that's it for those.